concepts of telepathy that people talked about now, or teleportation. You will see articles coming out, what I call Industry 6.0 era, when machines are taking over. To easy one is to embed nanoparticles in our material so that you don't have to wash your clothes. So the pharma industry is talking about building new drugs to sell, rather than actually saying that I want to improve the quality of the health of people.
Hi, my name is Will Snow, and we are live with Date with Tech from the conference where we are doing data and care today. Today, I'm so honored to have Dr. Priyadarshy, former chief data scientist from Halliburton. Welcome.
Thank you so much for this opportunity to be at the podcast at Date with Tech. It's amazing title, right? Date with Tech.
It's fantastic. Right. It fits everything. And I've been so excited to have this conversation with you. I know the industries are changing and things are rapidly evolving, moving across from AI to robotics to quantum computing. And I think before we dive into the deep tech side of things, could you just give our guests a little bit of background about yourself?
I am Dr. Satyam Priyadarshy, and I'm the founder of Reignite Future. I am also recognized as the first chief data scientist of the oil and gas industry when I joined a company back in 2014 in the US. But I've been in the space for quite some time. But my background is I have a PhD in quantum long time ago from IIT Bombay. And since then, I've moved on to US, and that's where I live. And I worked in various fields of science, and I've been a visiting chair professor at Center of Oil and Gas and Energy, and few other places around the world. So I enjoy the corporate world as much as I enjoy the academic world.
Amazing. And you're also in the world of teaching. You're a professor, from what I understand.
That's right. I'm currently a visiting chair professor at IIT Bombay in the Center of Oil and Gas, and an adjunct professor at Virginia Tech, Oklahoma State over the years. And I think in my whole life, maybe about 8 years, I was never had a professorship. But otherwise, along with my corporate roles, I always had some kind of.
Fantastic. You're one of our few guests that really bridge a lot of the aspects or pillars, all the way from education to technology to business. Tell us a little bit more about influencing young minds.
Yeah, so you see, as you mentioned in your opening comment, we hear about a lot of these technologies like robotics and AI and etc. But if you look at the history in the last 30 years, the pace of evolution of technology has significantly increased, as we call them. That's why we use the term called exponential technology. At the same, why are they called exponential technology? Because it's just the ability to create value, and value could be defined for different organizations in different way, but it generates value on an exponential trend. Now, if you look at the current generation, these people are born with those kind of technologies. So yes, they are very good at using the technology and they get influenced by it. So hence, it's a role of coaches, mentors, and managers, leaders to bring this new generation workforce into so-called, in quote, old industries with the Stone Age thinking.
Yeah.
I call them Stone Age thinking industries. And that's where the role of people like us exists, because we have been in the industry and we know how to communicate the message right in the right environment.
Yeah, it's a big piece on digital transformation. Let's jump into that with these young professionals coming out of the universities. How do you think they can transform the minds of conservative industries, or these Stone Age businesses, as you put them?
Yeah, so that's a two-way traffic, right? Digital transformation, as we in industry, I think we are like most industries are pretty backwards in that sense. They are still talking about the concept called digitalization. They are still not talking about digital transformation in the full sense, because when you discuss in industry, they will say we want to do change management, and change management by itself is slow and incremental. But what we have to talk about transformation management, we should look at this younger generation and look at the previous generation and see how they have transformed. They don't do anything incremental, right? They are just leapfrogging. And industries have to do that as well. Bringing those young generation into workforce requires these leaders to transform more than those people. But they lack the experience. So that's where the leaders' tacit knowledge comes into play to actually tell them how and what a business is about and how do we grow it.
Yeah, I think as humans, we fear change a lot of the time. And I think even the older generations, we have to adapt to the new ways of working, new pieces of technology. and ultimately not feel threatened by them and really embrace them. I also think about your career and your background. You obviously brought data science to the oil and gas sector. What opportunities do you think from your experience our audiences can learn from implementing that experience with new technologies?
No, I think if look at oil and gas is one example, but where we are in today's world, as we know that in parallel to Date with Tech, we have CARE, the other conference going on climate and
Yeah,
sustainability and other resilience. If you think of it, what is the fundamental? Fundamental is energy, irrespective of whatever we can talk about. Energy security is the most important thing. We can't live without energy. Whether it comes from oil and gas, whether it comes from renewables, whether it comes from God knows from space, right? Doesn't matter, right?
for sure.
But energy is the critical part. How do I build, get energy at the lowest cost possible, which is resilient, sustainable, and does not impact the climate as such, so to say, right? For that, how can we do that is where we can actually leverage these exponential technologies. So most people usually talk about AI or digital transformation as two part, but if you look at it, there are other technologies which are critical in this space. One is nanotechnology. Without nanotechnology, most of these things we would not be talking about. So one has to really learn multiple disruptive technologies at the same time to make some sense.
Yeah, and you touched on so many, even like touching on nano and energy. Energy is obviously a big one with AI being used. I think it's using 1.5% of the world's global energy now.
Well,
Where do you see that heading?
those statements are right. Okay, the computing power is increasing as a result. Or computing systems use a lot more energy. Correct, that is true. But if you look at the history of computer evolution, is as well, we have increased the power of computing and we have reduced the footprint total. Correct. But at the same time, with whenever a new model or new method is evolved, people don't initially think of, oh, let's optimize energy first. They are thinking of building an algorithm, they are building a solution or a software
That's so
or a
true.
hardware so that it can function. And once it's done, then there are people who will sit down and say, how do I optimize various
The
pieces of the
efficiency.
puzzle? Efficiency will be there. So I don't see that as a negative point. I see it as a part of life cycle, that at some point people will start thinking, do I really need to have a so-called generic large language model, right? Especially, let's say, if we talk about oil and gas or any other energy company, I think the large language model don't work. We have to do what is called technology language models, because
Yeah.
we don't write English. If you look at a report of a technical report, we don't write English. We write abbreviations, 3-letter words, 4-letter words, which mean nothing to anyone except the people in the industry. So we have to build models on that data rather than the data on Shakespeare's.
Yeah. Yeah. I think you're saying build models that are very specific to their needs.
Correct.
I often wonder about like jumping onto LLMs. Will they ever get to a point where they speak their own language and we lose control of them?
That's all. I think I don't believe in such things much, because how can they build yes, they can build their own language, but over the years people have been saying, look, people can write the code. But if you look at any of these LLMs, you can write some basic code. If you don't even know the science problem, how do you write the code? Correct.
Yeah.
So
Correct.
even if you thought of giving sequence of commands, it will write certain part of the code. Human cognition has to get into it to refine the code. So can it be 100%? I don't think so. Not in my lifetime, at least. Maybe in yours, since you are young, but not in my lifetime.
Interesting. Yeah, it's a very interesting topic. I tend to agree with you. Of course, human in the loop with all these systems is where we are right now. And I also think AI to serve humanity as opposed to AI that serves AI.
That is true. Like, people, even in AI community and other communities, where are people using this? For example, comes to drug discovery, right? We still talk about AI in drug discovery, but not actually saying AI for good health. So the pharma industry is talking about building new drugs to sell, rather
Yeah.
than actually saying that I want to improve the quality of the health of people. Right? The concept was evolved called personalized medicine in the modern times, in the last 10-15 years. But you tell me, with all these algorithms, what personalized medicine have you actually received? Right?
Yeah,
So
for sure.
so
It's a
so
very
the
good point.
focus currently of most of these AI things is actually how to make money for the industry rather than actually improving the humanity at this point.
Yeah, I do tend to agree with you. Of late, I've started to see more people focusing on sustainability, climate change. So I think that is up and coming, but definitely I think commercialization was at the front of all of this.
Absolutely.
Which naturally I think it is, that's the natural progression of these things for humanity. We also touched a little bit on nanotechnology and robotics. How do you see that playing into current trends with everything happening in the East and in the West?
I think nanotechnology is a fundamental for many things, right? If you look at it, because at the end of the day, you have interactions at a very microscopic level, right? So everything that works on it, whether it comes to building new materials that are for sustainable world, all right, whether it is, in fact, we're sitting here in Dubai. If you want to build new kind of cement for the weather that is being changing so drastically in various parts of east or west, right? You have to build new materials, whether you want to keep your building cool or hot, right? How much can you actually rely on air conditioning systems and other things? So can we build materials to cover the building, cover the roof, whatever it is? Or the paints, people have been experimenting with building with different kind of paints to reflect or observe depending on what you want to do. But at the same time, its application, whether it is related to water streams, whether it is related to wind farms, right? All these places you see applications of nanotechnology, whether in terms of nanodots, whether it is terms of materials, embedding. In fact, clothes nowadays, right? If you look at it, many years ago, there was a big advertising for one of the detergent powder that it has nanoparticles, but then it got in trouble for various
Very
reasons.
interesting.
So, right. So people have been like, experimenting with this, and I think it's a field that where we have to watch out and see how it grows. But I think on the concept of robotics, I think that has now we see a lot of applications in big complexes, especially I think there was in news recently the the fiber cut for the internet, right? A few couple of months back,
Okay.
let's see fiber internet cable down something. If you have to repair those things, it's an expensive business.
For sure.
Hopefully robots can be built so that in future we can reduce the time to repair such things. And people are using those kind of technology in offshore platforms in oil and gas. People are using similar kind of robots in college campuses, right, to deliver food. So the robots are taking over. So I think we are in what I call industry 6.0 era, when machines are taking over to some extent.
Yeah, it's very interesting. I believe there's that home bot, I think it's called Neo, that's also just recently launched. And obviously, it's not being run by any sort of AI at the moment. It's somebody controlling it, which also kind of brings in a lot of somebody else is controlling a robot that has a view into your home, which brings in a lot of privacy conversations. But it is interesting to see how robotics are evolving, both out of not just industry, but into our homes.
Absolutely.
Yeah. And just coming back to nanotechnology, do you see any application for it that consumers would be seeing around?
I think, as I said, you can see quite a bit in medical science. You can actually build these cameras that are so small, which can collect the information from inside the guts, so to say. And when it comes to, as I said, one of the really easy one is to embed nanoparticles in our material so that you don't have to wash your clothes, maybe, right?
Yeah, for sure.
Right? Or at least iron them regularly, right? So that's where some of the consumer applications,
It's already being
especially
used.
improving the quality of detergents, is there. If you look at day-to-day life, there's certainly some great areas for it.
Very interesting. Very interesting. I think that kind of closes a little bit on the nanotechnology and the robotic side of things and how consumers might see it in their everyday lives. Now, moving into the realm of quantum, I know this is a very complex topic, and not many people understand it. But if you had to explain quantum to me as a 5-year-old, what would you say?
Wow, that's a tough question. But I think since I did my PhD in that subject, what I can say is, if you look from a philosophical point of view, quantum has been there forever. It is our ability to understand has been limited. But if you look at the history of quantum mechanics, almost this is the 100th year of quantum they are celebrating in modern times. But if I go back to the literature of India, actually all the ancient literature like Vedas and others, quantum has been talked about in various terms. So we are all interconnected particles. If you want to think of it as yourself as a particle, not as a wave. So we are all there. Concepts of telepathy that people talked about now, or teleportation. You will see articles coming out today in magazines that we have done teleportation over 2 kilometers, right?
Correct.
So these concepts have been talked about there long before. So now science has evolved to a point that they can actually check and see that these things are possible. So I think quantum is always there, and quantum will always remain there. It's not going there. The question is, how fast can we evolve to understand it?
And obviously, this is coming big into the computing side of things.
Correct.
There's quantum hybrid and quantum computers. How fast do you think that's actually going to become applicable to the markets?
One is, yes, quantum computer hardware is evolving, and it's evolving pretty fast if you look at the last 10 years trajectory. And as a result, applications will keep growing. When we ask the question how fast, people are looking at terms of commercially viable, right? So that is, there is still some time, but as far as where the system will evolve, we will probably see some use case in, say, fintech or something that could be mature, which could be commercially viable. So compared to current, a same problem solved on a regular computer versus on a quantum computer, I'm talking about quantum computer as hardware, is much faster and much more efficient and still cost effective, right?
Okay.
Then when that happens, I think suddenly you will see that everybody wants to invest in quantum computers. Correct, because now say, oh, something is unique happening,
Yeah.
even though people are investing in it, but I think that's the people are looking for commercial
Still
value.
early days.
But from a concept point of view, I think quantum is here and quantum is important, and I think it also applies to global security as well. Quantum security
Yeah.
will be very important. Leveraging that is will be very important in near, I would say, in short period of time.
As it comes online, I do worry about like banking security. Obviously, this will have the capabilities to break hash keys and security chains. Let's take a point of view from the regulators. How do you think we regulate quantum?
So as if you look at any of these exponential technologies, right, whether it was big data, then whether it is artificial intelligence, now generative AI, right, or agentic AI, if you look at how regulators work, right, it's a collaborative effort. Nobody really knows what's the 100% future it is. So they all learn in the process and actually develop these policies, frameworks, or governance frameworks, right? So I think, and it's a collaborative among various countries, various organizations, private public partnership, all of them have to come together. So
Yeah.
balance the economic side, the technology side, the application side, the humanity side. So I think it's a combination of things. I don't think anybody has a blueprint or this should be the thing for 5 years.
Answers, yeah. Dr. Priyadarshy, it's so great to have you. I wish we had time to talk about all these things further.
No,
Thank you so much for your time today.
thank you so much. Thanks very much.